want to show you how to do today is to determine whether or not something is linear or nonlinear based on just being given ordered pairs. So we're going to do one example together. We're given down below, we're given 5 ordered pairs or points, and really there's 2 ways. There's probably more than 2 ways. There definitely is. But the 2 ways that I want to show you how to approach this problem would be number 1 with a graph and number 2 with a table. So if you're given ordered pairs and you're trying to determine if it's linear or not, I would go ahead and graph those ordered pairs. If it's linear, it's going to make a line. If it's not linear, it's not going to make a line. So let's go ahead and do it. I'm going to use the highlighter so the points are a little bit thicker. Okay, we have a point at 0, -1, and of course my graph does not have negative y values, but I'm going to put a point about there because that's where it should be. 1, 0, that's an x coordinate of 1 and a y coordinate of 0, so that one's here. 2, 3, so that's over 2 up 3. 3, 8, over 3 and up 8. Oh geez. And then I can't even fit my last point on that graph. But guess what? Just from the 4 points that I fit there, I can tell that this is not linear because those points do not make a straight line. If I tried to connect them, it would actually be curved. So that's definitely a no. Those are not linear. Or that function is not linear. The other way that I wanted to show you is just by figuring out the rate of change in a table. So basically, you just take those points and you plug them into a table. So I'm going to put them here: 0, -1, 1, 0, 2, 3, 3, 8, and 4, 15. So again, from the video that you watched earlier, we talked about how if it's linear, it has a constant rate of change. So that means that the slope will be the same no matter which 2 points you pick. So let's go ahead and start with the first 2 points and find the slope. To go from -1 to 0, I'm adding 1. And to go from 0 to 1, I'm also adding 1. So looking at those first 2 points, my slope's 1 over 1, or just 1. Now I'm going to look at the next, or the second point, and the third point. To go from 0 to 3, I'm adding 3. And to go from 1 to 2, I am adding 1. That's 3 over 1. I already know that this can't possibly be linear because the rate of change is different just from the first 2 examples. But I'm going to go ahead and do another one just to prove it. Okay, so to go from 3 to 8, I'm adding 5. And to go from 2 to 3, I'm adding 1. That has a rate of change of 5 over 1. Definitely not equivalent to 3 or 1. Lastly, to go from 8 to 15, I'm adding 7. And to go from 3 to 4, I'm adding 1. That one had a rate of change of 7. So again, this can't possibly be linear because the rate of change is not constant.